The Cartesian plane is a graph with two major axes. The horizontal axis is typically labeled the x-axis, whereas our vertical axis is typically labeled the y-axis. This is sometimes labeled f of x or whatever the function is. Now, here, the red line represents function y equals a function of x. The inputs are x values. The outputs are y values. The points x, y represents the pair x, f of x. The x-intercepts are where the function crosses the x-axis. And the y-intercepts, or y-intercept, I should say, is where the function crosses the y-axis. So if we consider this function above, compute the x-intercepts and the y-intercept. Now, this is a not so formal definition. It's more of an intuitive definition of what's going on. And these hopefully we'll understand, but there's a more formal definition that we have, and the x for the x-intercepts and the y-intercepts. The x-intercepts are the values of x such that f of x equals 0. And the y-intercept is the value of f of 0. As we go on, this will be a more useful definition moving forward and easier to compute. With the Cartesian plane, we have points, but we also have distances and midpoints. And these distances and midpoints can be very useful. So the point P on an xy plane is given by xy. And we must be careful here because we just use these open brackets to represent intervals. So we need to remember we're not taking the interval of the x-axis, we're talking about a point x1. Now, if we have more than one point, we typically label using subscripts. So point 1 is x1, y1, and point 2 is x2, y2. We will often want to know the difference between x1 and x2, or y1 and y2. And this is referred to as the change in x, or the change in y. We use this so often we give it special notation. We use delta x to represent x2 minus x1, and delta y to represent y2 minus y1. And what I like to think about here is delta equals final minus initial. And this is used everywhere. This is used a lot in chemistry, especially in thermodynamics. This is used a lot in physics. And it's used a lot in math. Now, when we're working with points, it's useful to know the distance between the points. We have the distances, or the change in x and change in y, but now we have our distance between 2 points. So if we look at the distance between P1 and P2, this is the square root of x2 minus x1 plus y2 minus y1, which is equal to delta x2 squared plus delta y2 squared. And the midpoint is the average of our x values and the average of our y. So for a suggested exercise, for each of the following points, compute the midpoints and the distance between the points. We're just going to do the first one together. So the distance between P1, P2, that distance is equal to 3 minus 1 squared plus 4 minus 1 squared, which equals the square root of 2 squared plus 3 squared, which equals the square root of 4 plus 9, which equals the square root of 13. And the midpoint is going to be 1 plus 3 over 2, 1 plus 4 over 2, which equals 4 over 2 plus 5 over, or 4 over 2 comma 5 over 2, which equals 2 comma 5 over 2. As a suggested exercise, complete the following two, or do the same for the following two sets of points. Now that we have our Cartesian plane, we're going to start talking about lines. Now, lines are super important. We're going to be using lines all over the place. And the first property of lines that we're going to talk about is called the steepness of the line. The steepness of the line is called the slope. The slope is typically denoted using an m. And m is equal to the rise over the run of the line, which is equal to delta y over delta x, or the change in y over the change in x. And if we take 2 points on the line, we can calculate the slope by taking y2 minus y1 divided by x2 minus x1. Now, using 2 points, if we have 2 points on the line, we can do a few more things. We can calculate an equation for the line. Now, there are 3 main equations for a line. We've got our point slope form, our slope intercept form, and our general form. Our point slope form takes the slope and a single point x1, y1 to build our line. The slope intercept form uses the slope and the y-intercept. So B is the y-intercept. And the general equation, we have constants A, B, and C, where both A and B are not equal to 0. There are many ways in which we can calculate a line. Here's one that visualizes the slope form of the line, that utilizes the point slope form of a line. When calculating the equation of a line, you select 2 points. We use the points on the line x1, y1, and x2, y2 to calculate m. Then we let y minus y1 equal mx minus x1, using the same point we use to calculate the slope. We use the same point. If you need the slope intersect form, expand the right side and isolate for y. If you need the general form, expand the right side and move everything to one side. I like this because it's super straightforward. Calculate m, plug in. If you need to isolate for y or to get your point slope intercept form, just expand and move everything over. You need general form, expand, move everything over to the other side. So for this line, let's calculate all 3 forms of the line. So first thing I'm going to do is I'm going to highlight 2 points. And my points are 1/2, 3/2, and 1 minus 1. From here, I'm going to start by solving for m. M equals, and I'm going to label this P1, and I'm going to label this P2. So it equals 3 over 2 minus 1 over 1/2 minus 1, which equals 3 over 2 plus 2 over 2 divided by 1 over 2 minus 2 over 2, which equals 5 over 2 divided by minus 1 over 2. And here I'm going to multiply by the reciprocal of the denominator to get 5 over 2 times minus 2 over 1, which equals minus 5. So my slope is minus 5. So y minus -1 equals minus 5, x minus 1. This is my point slope. Now, if I want my slope intercept form, I'm going to expand and get y by itself. So y equals minus 5x plus 5 minus 1. Y equals minus 5x plus 4. Now, if I'm going to go to standard form, I'm now going to bring everything over, which gives me 5x plus y minus 4 equals 0. I have my standard form. Here, I find this is the easiest way to get an equation for the line. And then to get your other forms, it's simply manipulating your function. As a suggested exercise, calculate the equation of these lines. Now, when we have 2 lines on a graph, there's different ways we can compare them or talk about them. The first thing is to determine whether or not they're parallel or perpendicular. Now, two lines are parallel if M1 equals M2, and they're perpendicular if M equals minus M1 equals minus 1 over M2, the negative reciprocal. Now, there's some issues when M2 equals 0. This definition works for lines that are not horizontal or vertical. If the lines are horizontal and vertical, we should have that all vertical lines are parallel to all other vertical lines. All horizontal lines are parallel to all horizontal lines, and all vertical lines are perpendicular to a horizontal line. So instead of trying to come up with a new definition for that case, what we do is we extend this definition by saying, if this is true and M1 does not equal 0 and M2 does not equal 0, then this expression. And we add that if we have vertical lines are parallel to vertical lines, horizontal lines are parallel to horizontal lines, and vertical lines are perpendicular to horizontal lines. For each of these lines that we've calculated above, compute lines that are perpendicular and parallel and pass through the origin. And the hint that I would give is use point slope form, because the origin is simple to use for point slope.